This is a 20-watt amplifier I made. It works on the 20 and 40 meter band, and I designed it for CW. I like Morse code. I'm not going to talk about the details of the amplifier or how many transistors I blew to understand these knockoff Chinese IRF 530Ns. All you need to know for this video is I designed the amplifier to drive a 50 ohm load, as most RF amplifiers are made to do. And if I hook the amplifier to a load that deviates far enough from 50 ohms, my amplifier gets hot and breaks. It has a meltdown. I want to protect my power amplifiers in my radio projects. So in this video, I build a generic device that will, 1, measure how close a load is to 50 ohms, and 2, alert the radio that the load isn't 50 ohms and that it should reduce power to the amplifier. I call this device, you guessed it, a how close is my load to a 50 ohms meter. And that's what this video is about. Turns out I'm not the first person to think up one of these how close is my load to 50 ohms meters. Here's a picture of one in my Kenwood TS130S radio. This circuit here determines if the load, the tuner, coax, and antenna combo, is close to 50 ohms. And if it is not close to 50 ohms, it alerts the rest of the radio that it needs to reduce power so that the power amplifier doesn't burn up. I think the circuit right here is used a lot. I've also seen it in my ICOM 7300. Rather than calling it how close is my load to 50 ohms meter, it's more often referred to as an SWR meter, or a standing wave ratio meter. That's actually just another interpretation of what an SWR meter does. It tells you how much your load deviates from 50 ohms. 50 ohms in most RF cases. A value of 1 means the load is exactly 50 ohms, and as the value of SWR gets larger, it means that the load is getting further and further away from 50 ohms. And that's exactly what I need. I know from my experimenting that I need to present a load that is around 50 ohms to my power amplifier so it doesn't burn up. The amplifier doesn't care if they're standing waves, it just cares if it sees 50 ohms or not. You're right. This is the worst etching job you have ever seen. I put in too much muriatic acid and not enough hydrogen peroxide. The toner on my printer was a little low too. Shoot. I fused another project box with this one, the one I just showed being made, and this helps isolate the RF side of the board with the control side of the board. This is the same RF part of the SWR meter I made in another video. I'll link that video below and at the end of this video if you want more details on this circuit. I use AD8307 logarithmic amplifiers to measure attenuated power from the input. Because they're logarithmic amplifiers, this circuit has great dynamic range, meaning I can easily measure fractions of a milliwatt to several hundred watts. The downside is that the accuracy isn't great. I think I can be off by as much as half a dB, or 10 or 15%. This isn't a problem for me though because I have a bird meter if I need more accuracy. I just want to be able to get an idea of what the power is and to measure the SWR for my homemade radios. A new addition from the other video I just mentioned is this chunk of aluminum I machined and placed between my two transformers. This makes a huge difference with respect to the coupler's directivity. Also see the other video if you need a refresher on directivity. This current sensing transformer and this trace that carries high current is isolated from this part of the circuit, where this is the voltage sensing transformer and this is all the circuitry for measuring power. By isolating this part of the circuit from this part of the circuit, I was able to improve the directivity by about a factor of 10. It was definitely worth adding this divider. Here's the finished meter all hooked up and ready to measure power and SWR. Calibration data is stored inside on an Arduino Nano, and I calibrated power using the bird meter. So how about a demonstration? My radio over there is connected through this bird meter and through my meter. The output of my meter is terminated in this antenna tuner that is connected directly to a 50 ohm load. The tuner is matched right now, so if I key up my radio and put 100 watts through it, the bird meter up here shows that I'm putting 100 watts through my meter. Remember, I'm not too worried about accuracy. For accurate measurements, I trust my bird meter more. Since the load looks like 50 ohms, little power is being reflected in port 1, and this is conveyed by this SWR value of 1. SWR of 1 means the load looks like 50 ohms. Now, I can pull the load away from 50 ohms using my tuner. You can see the SWR value change. And you can imagine if I have my tuner connected to an antenna and I'm getting an SWR of 2.5, I can use my tuner to bring the SWR back to 1. So it works. This meter is telling me by the SWR value how far my load is from 50 ohms. Okay, but now here's why I really made this meter. This knob right here allows me to set a trigger SWR value. I'm going to set it to 2. This means that if the SWR value becomes greater than this trigger value, an alert is going to be set. Let's try that. Here's 100 watts going in and no reflected power going back yet. But now if I change the SWR greater than 2, I'm going to get an alert. Pretend for a second that this LED represents an external radio. I have an external cord here that is intended to go back to a radio that I'm working on. If I try to put power through here and the SWR is greater than that trigger, the alert will send a signal back to the radio, telling the radio to reduce its power. If I want to turn that alert off, I will have to make sure that the antenna is tuned. And thereby saving my amplifiers. Pretty neat, eh? This will make a good addition to my homebrew radios. But there's more. There are a couple other features I added to this meter that I think are cool. First, I can power it either with a battery or through the signal wire. Right here on the screen, it shows the battery voltage level, so I know when to change the battery. Being battery powered is nice because I can use this as a general purpose power meter to read power everywhere from microwatts to a few hundred watts, and it's portable. I also think it's nice that it can be powered by an external 12-volt source, which means I can integrate it nicely with my radios. When I power this with an external source, as I'm doing right now, The battery voltage changes over to a message indicating that it's being powered by an auxiliary source. I also have the ability to view power in dBm. I can see that by hitting this mode button. So for 100 watts, I am getting about 50 dBm. I personally think more in terms of dBm, so it's nice to have the ability to toggle between the different modes. Power can be measured either direction through the meter, and to indicate which direction power is flowing for the SWR calculation, I have this switch. And this switch will change the sense in which the meter thinks power is going through. So if power were going through the other way, I could switch this over like this, and that arrow indicates that I would be measuring power this way. I can also turn the light on the LCD on and off to save power during battery operation. And now for my final and favorite feature. This Simpson meter isn't just here for clickbait. I can connect the Simpson meter into the meter I made into this port, and I can use the Simpson meter to directly view the measured SWR. And I find that really nice when I'm trying to tune in radios. The Simpson meter is actually measuring SWR -1. So on this scale, I can measure SWR everywhere from 1 to 11. Watch how nice it is to tune in the radio using the analog meter. See where it dipped? Minimum is right about there. And I like that way nicer than viewing just a digital SWR value to try to tune in a radio. I really like this. I have one more feature to show you before I sign off. I've been adding these holes to the side of my project boxes so that I can easily access the Arduino Nano and update the calibration data. After I'm done updating it, I add one of these little rubber grommets into the side. I think that makes a really nice little way of accessing the Arduino without having to open up the box. So where do I go from here? I'm going to be working on building a transmitter for my homebrew radio. I've already built a receiver that I think works pretty nice, so I need to get going on the transmitter. And when I build the power amplifier, which I'm hoping to make 100 or 200 watts, I'll be able to use this box to make sure that I don't blow anything up. By the way, I'm not planning on doing YouTube as a career, so please feel free to not subscribe or ring my bell. Hope you have a good evening. 73.